Good morning. So, building technology has two wings, the materials and construction. Construction has so many wings, such as planning, analysis, design, detailing, then execution. Materials has wings such as natural materials, semi natural materials, artificial or man made materials, synthetic materials. So, we will first concentrate on the building materials. Building materials for some time. So, to appreciate the quality of a material, its versatility in the construction practice, its usability, adaptability in construction practice can be appreciated only if we understand the strength of any material. The strength of any material decides its use as a particular component in building practice. So structurally, there is a term stress, S-T-R-E-S-S. Truss and stress are different, but unfortunately, some people call truss as a stress. Truss is a structural component, T-R-U-S-S. Stress is an internal resistance built up by the material property. Stress is an internal resistance built up. Stress is an effect, it is not the cause. Stress is an effect. Only if there is a cause, stress will build up. It's case of human beings also. Nobody will be under stress unless or otherwise there is some external influence, force, or interference. Then only stress will be built up. So the word has the literal meaning of building up some resistance, either biologically or structurally. So stress will not be there if there is no external disturbance. If there is an external disturbance, stress will start building up. In civil engineering terms, the external disturbance, whatever it may be, there are different types of external disturbances, is called a force. And when it comes to the building context, a structural context, it is called a load. When you take it as an analysis part, it is called a force. Up to analysis, it is a force. When it comes to the structural design, structural analysis, it is called a force. But once it comes to the structural design, it is called a load. Force and load are one of the same, as far as analysis and design are concerned. There are two types of materials. One is the rigid material, another is the flexible material. The stress developed in the material depends on its rigidity or flexibility. For all structural analysis, we assume reasonably all materials having rigidity reasonable. Then only if a material is rigid, it can transfer and it can develop a stress. Flexible materials, stress transfer will not be that much efficient. They will yield. You can see in persons also. Persons will not take up stress. They will release. That's the best thing as far as human psychology is concerned, as far as biological stress development is concerned, it is better to be flexible. Only rigid people who have a sort of rigidity in all their policies will have stress built up when there are external interferences, intrusions. If they are flexible, they can release the stress then and there. So flexibility is a value addition for personality development. But in structures, if structures are flexible, load transfer mechanism has to be difficult. It will be difficult. Only if structure is rigid, you can transfer the load. Flexibility and rigidity. And the rigid structures, when it is subjected to external loads, will deform. There will be deformation. That deformation shall not be mistaken as flexibility. As I told you yesterday, certain element, when some load is coming according to its fixity, according how you hold it, it will deform. All materials will deform to the external forces or loads. While deforming, they are transferring the load. They are building up stress too. But in the case of flexibility, they may not transfer the stress. That's the thing to be remembered. In the case of a perfect rigid body, for example, like this, a rigid body, if you apply a load, the shape or the form of this will not change. It will just bend as a straight line. This straight line will remain as a straight line even when an external force is applied. That is the perfect rigid bodies. In actual existence, no body is 100% rigid. When a load is applied, and according to the way in which it is held, when a load is applied, it will take a deformed shape. So the particle movement of this material will not be the same. But in the case of rigid, particles move, that relative displacement of each particle is zero. If it is rigid, relative displacement of each particle is zero. So a straight line will be a straight line again. The field of study dealing with rigid bodies. The field of study dealing with rigid bodies. That means the relative displacement of particle zero, by which a straight line remains a straight line even after the application of force, is called applied mechanics or engineering mechanics. Mechanics deals with bodies which are rigid, perfectly rigid, and their behavior, rigid body, their behavior for external forces. Engineering mechanics or applied mechanics deals with rigid bodies. But structural analysis, where you use different materials which are not perfectly rigid, they are deformable. They are deformable bodies. So structural mechanics, solid mechanics, or in other words, strength of materials. Strength of materials is also an analysis of forces, but they deal with deformable bodies. When a load comes, there will be relative displacement of particles. Particles will shift from their original position, and their shift, quantity of shift is not same for all the particles. According to the vicinity, according to the neighborhood, according to the nature of the external disturbance, the particles will start. But their continuity will be maintained. The continuum will be maintained. So they will start resisting, deforming themselves, deflecting themselves. So strength of materials or solid mechanics or mechanics of solids or structural mechanics deals with deformable bodies subjected to external forces or loads. Engineering mechanics or applied mechanics or mechanics deals with rigid bodies subjected to external forces. So we should know what are the external forces and what are the strength of the material. So once you want to know the strength of the materials, we are seeing stress, any arbitrary value. Stress is a result, we told. Stress is a result. It's an effect. What is the cause? Cause is the force. If there is a force, there will be a stress built up inside. According to the going on, increasing the force, there will be stress will go on increasing till the material is not at all capable again for more stress to be transferred. Material is incapable of taking more stress and the material fails. So the maximum stress up to which the material can take by the increment in the force, the external cause, that maximum stress is called strength of a material. So any arbitrary force induces a stress to the material, and that any arbitrary force inducing on the material is an arbitrary stress. And that stress will be well within its strength. According to the nature of the material, the strength will change. Strength is the maximum stress without the material getting broken. A failure will not take place. If you start loading the material or forcing the material more than that value, the material will fail. So strength and stress are related in such a way that stress is any arbitrary value because of the force, and strength is the maximum value of the stress. And that is the limit of the force. So usually nobody will load the material to its maximum value. We have to provide some reserve. The material, we have to provide some reserve. That reserve is called the factor of safety. Factor of safety means the reserve of stress available within the material. So the material at any case will not be loaded more than a particular value of stress. The material will not be loaded or forced more than a particular value of stress. That stress is called working stress. Working stress of a material. Strength is called the ultimate stress, ultimate or maximum stress. So ultimate stress is the maximum value, but all material will have a design value which is known as the working stress, and the ratio of this ultimate stress to the working stress, ultimate stress to the working stress is called factor of safety, FS. So factor of safety, the safety factor, usually safety factor is in another context it will come. Now we will denote this ratio as factor of safety. So factor of safety is the ratio of ultimate stress by working stress. If the factor of safety, it is a number. It doesn't have unit because numerator and denominator, they neutralize. The unit gets cancelled. So So it's a number. Suppose the factor of safety is 2. You are going to load the material only half. It is having a reserve of again 50%. 1.5 means according. So factor of safety is a reserve. It's a precaution given in for all materials so that they will not be loaded up to its strength or ultimate stress. Thank you very much. God bless.